My name is Amy Huff, and I'm a research scientist at Pennsylvania State University. I'm also an air quality forecaster for the Philadelphia metropolitan area and the state of Delaware. Today, I'm going to provide an overview of aerosol products from the Visible Infrared Imaging Radiometer Suite, or VIIRS. These products can be used for monitoring fire and smoke in the atmosphere. The VIIRS instrument is on the SWOMI National Polar Orbiting Partnership, or SNPP satellite. SNPP is a polar orbiting satellite with a low altitude orbit around the North and South Poles. It has an early afternoon overpass time, around 1:30 p.m. daily. That means there is only one set of observations from VIIRS per day during daylight hours. Due to time needed to process the aerosol products, near real-time observations from VIIRS are available in the mid-afternoon, typically about 2 to 3 hours after the satellite overpass. VIIRS is one of 5 instruments on SNPP. It has 22 spectral bands with high spatial resolution. VIIRS is similar to the MODIS instrument on the Terra and Aqua satellites. The most commonly used aerosol product for monitoring fire and smoke in the atmosphere is aerosol optical thickness, AOT, sometimes called aerosol optical depth, AOD. AOT is a measure of the scattering and absorption of visible light by particles in a vertical column of the atmosphere. It is not a direct measurement made by VIIRS. Instead, an algorithm is used to calculate AOT from VIIRS measurements at various wavelengths in the visible through the infrared. The most challenging part of developing an AOT algorithm is to distinguish aerosols from clouds and bright surfaces. The advantage of a multi-channel instrument like VIIRS is that measurements from various channels can be used to determine the contributions from the surface reflectance and clouds. Typically, there are different AOT algorithms for retrievals over land and over the ocean. AOT is unitless and typically ranges from 0 to 1 in the US, with higher values indicating higher concentrations of aerosols in the atmosphere. AOT is usually color-coded in imagery, with cool colors, blues and greens, corresponding to lower AOT, and hot colors, oranges, yellows, and reds, corresponding to higher AOT. Clouds block the measurement of AOT, so there are no measurements in cloudy regions, and AOT is not retrieved over areas covered by snow. AOT is useful for tracking the geographic extent and transport of smoke plumes, because smoke has very high concentrations of aerosols, with AOT values as high as 4. In this example from August 29, 2015, you can see high AOT, the red colors, associated with a smoke plume in the northern plains of the US. VIIRS also features a smoke mask, which is a qualitative indicator of smoke originating from burning fires in the region or transported smoke from upwind. The smoke mask is derived using spectral and spatial threshold tests based on VIIRS measurements in the visible and infrared wavelengths. The smoke mask is a quick way to see the location and extent of smoke plumes. The VIIRS smoke mask is colored in shades of pink, where light pink indicates thin smoke and magenta indicates thick smoke. In this example from August 24, 2015, you can see quite a bit of smoke from fires in the Pacific Northwest, as well as some more localized smoke in the southeastern US. VIIRS also senses the locations of fires as hotspots, represented in imagery by red dots. The quantitative measure of fire intensity is given by the VIIRS fire radiative power, or FRP, which is indicated by the size of the dots, with larger dots corresponding to higher values of FRP. In this same example as from the previous slide, for August 24, 2015, we're zoomed into the fires in the Pacific Northwest, showing the many fires across the region indicated by the red dots. Also available is the VIIRS satellite-derived PM2.5 concentration in units of micrograms per cubic meter. PM2.5 is a criteria air pollutant, and it's a general name for particles in the atmosphere with aerodynamic diameters less than or equal to 2.5 microns. These very small aerosols are a health hazard because they can penetrate deep into the lungs and cross into the bloodstream. VIIRS AOT measurements are used to estimate surface PM2.5 concentrations based on established relationships between AOT and surface PM2.5 concentrations. The satellite-derived PM2.5 estimates provide an idea of the health risk of smoke in the atmosphere. The orange and red colors correspond to PM2.5 concentrations that exceed the daily National Ambient Air Quality Standard, or NAAQS, for PM2.5. On this day, August 19, 2015, the satellite-derived PM2.5 product indicated that there were high concentrations of PM2.5 associated with the smoke plume over the Pacific Northwest. Note that in some cases, data will be missing. This can be due to a lack of AOT observed data because of cloud cover, for example. Remember, the satellite-derived PM2.5 data are derived from AOT measurements. Or missing data can be due to a lack of a strong correlation relationship between AOT and surface PM2.5, which is most common in the western U.S. VIIRS aerosol products, such as AOT and the smoke mask, are column measurements, so they do not provide any information about the location of an aerosol-rich plume in a vertical column of the atmosphere, or its likelihood to mix to the surface. It is important to remember that VIIRS does not measure AOT or estimated PM2.5 at the surface. In fact, VIIRS will often indicate areas of smoke that are aloft in the atmosphere. To know if the smoke is reaching the surface, look at the ambient PM2.5 concentrations from the AirNow network, which are available as a complement to the satellite-derived PM2.5 values. The AirNow ambient surface PM2.5 concentrations are dots, colored to the same scale as the satellite-derived PM2.5, which you can see at the top, in units of micrograms per cubic meter. High ambient PM2.5, the orange and red colored dots, tell you that smoke is reaching the surface. The ambient PM2.5 data also indicate the accuracy of the satellite-derived PM2.5 product. In this case, from August 19, 2015, the ambient PM2.5 dots show that smoke was mixing to the surface in the Pacific Northwest, as indicated by the red and orange dots, and you can see them in Washington State, Oregon, and Idaho. VIIRS True Color imagery is also available as a complement to the aerosol products. True Color imagery is made from a combination of the red, green, and blue bands of the VIIRS instrument. It is abbreviated RGB for red, green, blue. True Color imagery looks like a picture or a photograph, so it is easy to visually pick out smoke. In this example from August 29, 2015, you can see bright white clouds, green forests and grassland, brown mountains and deserts, and blue oceans and lakes. Smoke is a diffuse gray feature, such as the smoke plume shown here in the central U.S. that's encircled by the red circle. As I mentioned, AOT and True Color imagery complement each other. You can use them together to quickly identify smoke plumes. In this example from August 10, 2014, you can see widespread thick smoke plumes in the True Color image on the left. Those are those gray diffuse features, along with the red fire hotspot detections. The AOT image on the right shows the high AOT associated with the smoke plumes, and those are the red, orange, and yellow colors. In situations when forecasters need to predict whether a smoke plume will impact surface conditions, forward air mass trajectories based on AOT are informative. The trajectories are initiated at 50, 100, 150, and 200 millibars above the surface level, so in the boundary layer or close to it, in locations with high observed AOT, so that's AOT greater than 0.4. The trajectories are run 48 hours into the future in 3-hour time steps using meteorological predictions from the 12 UTC run of the North American model, the NAM meteorological model. The pressure levels of the trajectories are plotted in millibars and colored to a magenta white scale, and you can see the scale both for the AOD or AOT, remember they're essentially synonyms, as well as the trajectory pressures at the bottom of the image. So as the trajectories progress in time, magenta color trajectories indicate a flow of air towards the surface, with a potential similar movement of aerosols. White color trajectories indicate upward movement in the airflow away from the surface. So the idea is that where you see magenta trajectories, smoke plumes are expected to impact the boundary layer. 850 millibar wind field vectors are also plotted as white arrows to show wind direction and speed. Locations where forecasted 3-hour accumulated precipitation is greater than 2 kilograms per square meter are shaded yellow and represent the potential for wet deposition in areas of high aerosol loading. All of the VIIRS aerosol products are available in near real time from a new website called eIdea, which is shown here. You can find eIdea by Googling NOAA eIdea or by typing the eIdea URL shown here at the top. eIdea also has archived imagery going back to February 2016, in addition to the near real-time imagery. eIdea's domain covers the continental United States, so the CONUS, Alaska, and Canada, and the domain will be expanded to include Mexico, Central America, and the Atlantic Ocean in the near future. For more information on how to use and navigate eIdea, view the separate tutorial on eIdea.